We need to find out the value of sine 65 degree plus cosine of 65 degree. Now to solve this problem, we'll be using the transformation formula. However, there's a small problem here. The problem is we can only apply the transformation formula when both of the two functions are exactly the same. That means if we have sine 65 degree, then we should have the second term in terms of sine function, or both of them should be in terms of cosine. But that's not a big issue. We can convert the cosine to sine such that we have the sum of two sine function, or we can go the other way around, convert the sine to cosine in order to have the sum of two cosine function. So let's try to do that. So we have sine 65 degrees plus cosine of 65 degrees. So let's try to change cosine to sine. To do this, all we have to do is first rewrite the angle 65 degree of cosine. So here we have cosine of 65 degree, but we know that if we subtract 25 degree from 90 degree, that's also 65 degree. But there's a reason why we're writing in this fashion, because we know for a fact that if we have cosine of 90 degree minus theta, so that's equals to sine theta. Meaning, in place of cosine 90 minus 25 degree, we can have sine 25 degree. So our expression now becomes sine 65 degrees plus sine 25 degrees. Right. So what we've done, we have successfully converted the second term, which is a cosine function, into a sine function. Similarly, what we can do, we can convert the sine to cosine. So let's do that here as well. We have sine 65 degree, but what we'll do, we'll rewrite 65 degree of the sine as 90 degree minus 25 degree. But we're going to keep the second term as cosine only. We have cosine of 65 degree. Now we'll be using the fact here that if we have sine 90 degree minus theta, so that's equivalent to cosine theta, which means that our first term, sine 90 minus 25, will become cosine 25 degree. So we have cosine 25 plus cosine 65 degree. So we have successfully converted the first term, which was sine, to cosine, so that we have the sum of two cosine functions. Now we are ready to apply the transformation formula. So if we have the sum of two sine function, so that can be also expressed or transformed as a product of two trig function. One will be sine and the other will be cosine. And if we have the sum of two cosine function, so that becomes the product of two cosine function. So let us apply. So in our case, we have sine 65 degrees plus sine 25 degrees. So here we will consider alpha to be 65 degrees and beta to be 25 degrees. So this is going to give us 2 times sine of 65 degrees plus 25 degrees divided by 2. And then we have cosine of 65 degrees minus 25 degrees divided by 2. Fine. So we get 2 times sine. So 65 plus 25, that's 90 degrees. So 90 over 2 is going to be 45 degrees. Multiplied to cosine of, so 65 minus 20, that's going to be 40 degrees. So 40 over 2 is going to be 20 degrees. Now we know the standard value of sine 45 degrees, so that's 1 over square root of 2. So we have 2 times 1 over square root of 2 times 20 degree, and if we rationalize the denominator, we're going to get square root of 2 times cosine of 20 degrees. Similarly, if we use the second transformation formula, then we have cosine of, let's write 65 degree first, added to cosine of 25 degree. So here, alpha is 65 and beta is 25. And this is going to give us 2 times cosine of 65 plus 25, so that's going to be 90. 90 over 2 is going to be 45 degree, multiplied to cosine of 65 minus 25, which is 40. 40 over 2 is going to be 20 degree. So cosine 45, that's also 1 over square root of 2. So we get 2 times 1 over square root of 2 times cosine 20 degree. So this way also we're getting the same result, which is square root of 2 times cosine of 20 degree. So let's go to a problem. So we have square root of 2 times cosine of 20 degree. That means option 3 is correct. However, there is one more option that's going to be correct, and that's number 5. The reason behind this, because we can convert cosine to the sine function. We know that sine 90 degree minus theta, so that's equals to cosine theta. We've already talked about it. So if we consider cosine to be equals to 20 degree, then we have cosine of 20 degrees equals to sine 90 minus 20. So what's sine 90 minus 20? That's only sine 70 degree. So cosine 20 degree can be also expressed as sine 70 degree. And since in our result we obtain square root of 2 times cosine 20 degree, so we can replace this cosine 20 with sine 70 and we get option number 5, which is square root of 2 times sine 70 degrees.